We've been investigating end behavior in horizontal asymptotes by using limits as x approaches infinity or negative infinity to see how functions behave. In particular, I want to talk about 3D and 3E from our assignment. So when we're working with a limit, like limit as x approaches infinity, and we'll talk about negative infinity in a minute, but of absolute value of x over x, like our algebra problems that involve absolute values, we really have to consider this as two functions. So the absolute value of x behaves one way when x is greater than 0. So when x is greater than 0, absolute value of x is actually just x. So this expression becomes x over x, which is a 1. But when x is less than 0, when x is less than 0, my eraser. Oh, that's not an eraser either. This is a colossal mess, isn't it? All right. Let's see if I can erase this other stuff. Nope. You'd think I'd start this video over, but I'm not going to. Let's just do this. When x is less than 0, this function behaves differently. When x is negative, the absolute value of x is the opposite of that negative number to make it positive. So this expression, absolute value of x over x, actually behaves like negative x over x when x is less than 0. And so in that case, this behaves like a negative 1. So as we're investigating these limits at positive and negative infinity, we have to consider the signs of the x values. When we're going to positive infinity, our function is going to behave like this, and it's going to be y equals 0. Why am I saying y equals 0? It's going to behave like y equals 1 for an asymptote. And we could probably argue about whether or not this is actually an asymptote, because if you graph this thing, it basically just looks like two lines. There's a line over here, and there's a line down here, right? It's not really asymptotes. But we're going to call them asymptotes for the sake of this question. So when x goes to positive infinity, we have to follow this top rule. When x goes to negative infinity, the absolute value of that negative number turns to be the opposite, the positive. And so we get this fraction. We have to follow this rule. And that's why we have y equals negative 1. So for letter D, the end behavior at positive infinity is y equals 1. And the end behavior at negative infinity is y equals negative 1. I stumbled horribly through that problem, but I hope you agree with me that when you have an absolute value in your problem, you have to consider both cases. The case where the stuff inside is positive, that's this, and the case where the stuff inside is negative. And we did that, and we ended up with two different horizontal lines depending on where we were on the x-axis. So then you come to letter E. And letter E is all kinds of interesting. We want to look at the degree of these functions in the numerator and the denominator and make a decision about whether this is a 0 or a horizontal asymptote that's not y equals 0 or undefined or infinity. But we're struggling because this square root of this binomial is not easy to deal with. So the way I usually tell students to handle this is, don't worry about actually figuring out the square root of x squared plus 2. Instead, what you can do is just do the square root of x squared, because our function is going to behave like that for the most part. There's a shift involved in there, but essentially this function behaves the same as the square root of x squared. And it's not commonly remembered, but the square root of x squared is actually the absolute value of x. And the reason that is when you plug in a negative number, you square it and then take the square root, you end up with the opposite of what you started with. You started with a negative, you end up with a positive. So when you are talking about the square root of x squared, which we are right here, we want to think of that as the absolute value of x. On the denominator, we just have this x minus 5. Again, we're only worried about the leading coefficient. And that leading term is degree 1. That's just an x. So the degrees on these are the same. We're going to have a horizontal asymptote. We just need to be careful how we think about it. And it turns out you think about the same way you did letter D. So we have to consider both cases. When x is positive, this function, absolute value of x over x, behaves like 1, right? Y equals 1. X over x is 1. When x is negative, this function is a positive over a negative, and it behaves like a negative 1. So when you graph either of these functions and you look at its end behavior, both of them behave like y equals 1 on the positive end and like y equals negative 1 on the negative end. You can verify this by just graphing these functions in Desmos. I'm not going to add that into this particular video, but give that a try, and you'll see that at the ends, when we head towards infinity and negative infinity, the left and right ends, the function indeed behaves like y equals 1 on the right and y equals negative 1 on the left. And that's true of both these functions, even though they look quite different. Okay, I hope that helped a little bit with number 3. Of course, if you have more questions, you know where to find me. Take care.